You are listening to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the advancing journeyman developer.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast. This episode is sponsored by Datadog.
I was normal once.
Really? What happened?
I got better. Working with databases can be anything but normal. However, when working with relational databases, you want to normalize your schemas as much as possible to improve organization, storage, and performance. We're going to talk about why you want to normalize your database and then get into the different normal forms, focusing specifically on the first three and the Boyce Codd normal form. But before we get started, Will, what have you been fighting this week?
Man, there's been all kinds of interesting things. I've been playing around with knockout components. I've been trying to stand up a personal website with Hexo. I completely destroyed my EJS templates, and I pulled back from Git. I did a Git revert, and yeah, apparently what I checked in before was broken, so I've got to go back through. It's been a comedy of errors, just on and on.
You need to give me access to that repo so I can go in and look. I want to see what you broke.
I think what I'm going to end up doing is just making my own theme, because I was taking somebody else's and trying to modify it. And that's dumb.
That never works because you don't know why they did things certain ways.
Yeah. And it's in a language, I'm not really used to the templating, the EJS stuff and all that. And I'm like, why am I doing this? I would tell a junior developer not to do it this way. And here I am. So I'm probably just going to make my own theme and just be done with it and do it from scratch.
That's a good idea. What I did when I created your business website, because you wanted it to look just like your WordPress site was, is I took an existing theme and I had it to the side.
Yeah.
And I could look at it while I was creating the theme.
Yeah. The only other thing I've really done is I finally have kind of caught up on the emails. I mean, I still got to schedule them all, but I got them written. It's taking me longer and longer to write the email newsletter because there's more stuff in it now than there used to be. Mm-hmm. And it's a little bit more thought out. Part of it's just finding my voice. So guys, if you're not a subscriber to our newsletter, get on and subscribe. We haven't really been pushing it that much because we've been building up our talents. Yeah. In other words, that's a nice way to say that I'm trying to get where I'm not terrible.
And if you want to see this process, you should get on it because it's really good. He writes a lot of great stuff. Occasionally I disagree with him and tell him about it. But,
at length.
Not publicly.
On Hangouts.
Yeah.
At 11:30 at night. On Thursday. So I wake up Friday morning and the green light's flashing on my phone. And I'm like, yeah. I'm just kidding. I have you blocked. No.
I would too, but
I have the notifications paused when I'm asleep.
Yeah.
So how about you?
Well, I've been doing some refactoring of one of the apps that I inherited. There's a lot that needs to be done on this one, but I'm kind of taking it one step at a time. Whenever I'm asked to make an update or a change to something, I go in and refactor one area when I make those changes. That way it's not pulling from my regular work, but over time, the app is getting better with each change I make. It's one of those things that the developer before me was also a junior developer, and you could see where he was learning things as he was going. If you looked at the current app I'm working on right now, you would see a few spots where there's some older code that I haven't gotten to refactor yet, but my goal is by the time this application goes into production, I will have refactored everything so that even if I don't have the newest stuff I've learned in there, it all looks the same. And it has all the same feel throughout the entire application.
Yeah, that's a hard thing to maintain because what I'm doing on the app I'm working on, I can fix a few things on any given iteration, but I can't fix all the things. And then I do the next piece. And, you can go back and fix it for a little while, but after a while, you start getting 3 or 4 iterations in. It's you can't go back and correct it. So you have this kind of lava flow pattern.
Mm-hmm. Well, what I'm trying to do is just do the things that annoy me the most and get those solved.
Yeah.
I had a long weekend because today is President's Day. So yesterday I went down to my mom's and set up a small archery range for myself. One of our really good friends gave me some old targets that he had. that he wasn't using anymore. And then, of course, my dad gave me the bow for Christmas. Haven't had a chance to use it until this past weekend. That was a lot of fun. I am sore from several hours being out there shooting a bow. That's a workout, man.
Yeah, I mean, when I was a kid, before bow season, well, I say I was a kid, I was a young teenager and on up. My dad's thing was, I think I had to shoot 200 shots a day for like a month before hunting season. Yeah. Every day.
Ooh, man.
Because he was like, I don't want you to wound an animal, because like you're making something suffer for longer.
Right.
And it was that. And then he's also like, yeah, because then I know who's going to be trailing that thing through the woods in the dark. Mm-hmm. I think that was probably more of it. But yeah, I remember the soreness, and it's always like it's on the edge of the shoulder blade is where it always got me.
Rhomboids.
Yeah.
My problem is actually my left elbow.
Okay.
Holding the bow out.
You locking your elbow maybe?
No, but I'm not used to a lot of movement or a lot of like.
Yeah.
So that it just that joint is stiff.
Yeah, and it may be some early signs of arthritis too.
Well,
that I don't know. If I shot now, I might have the same problem.
Well, the other
thing is we're old.
Well, the last time I shot a bow was at your parents' house.
Yeah, that's been a while.
Yeah. But speaking of archery, I have something bow related for IoTs. This week for IoTs, I have an interesting app called the Velocitip Uno app. Now, this app was created by Full Flight Technology. It's a company that built a system for measuring ballistic information from an electronic field tip that you put on an arrow. And while the ballistic system is really fascinating, I kind of looked at it. Its price pretty much puts it exclusively in the range of serious competition archers. The Uno app, however, will help any amateur archer like myself to sight in their bows. To use it, you just sight in at one distance and then provide the app with certain information. It'll then customize the pin selection for any setup so that you don't have to sight it in at different distances. All you have to do is just match display on your phone screen.
Pretty cool. And, I'm sure there's people out there that would have thought that Uno was the precursor to DOS.
Well, that's true. That's true. So who's talking to us this week?
You didn't like my dad joke, did you?
No, I just moved right on.
Yeah. It's probably best. Don't look at it. He'll only encourage it. So we got an email from Joe Graff. Said, on the show, Continuous Self-Improvement, towards the end of the show, you mentioned Knockout.js like it was a bad thing to be using it. I work for a big insurance company building internal web apps to help automate things. Knockout.js goes on everything I do because it is a simple framework for data binding. I've tried to see if there was something else out there that didn't require you to use new languages in addition to a JavaScript framework. For instance, AngularJS seems like you have to use Node to use it, plus the syntax is weird. With Knockout, you can use it or not use it. It pretty much does one thing, and it does it really well. I'm not trying to be a downer, but when you hear comments like yours, it also makes you second guess your framework of choice. Then again, what else is there? Vue.js, Backbone.js, Angular. So I'll go ahead and kind of answer this. Knockout's awesome. I use it. I'm doing Knockout components. That's going on basically every new thing I'm doing as well. The reason that it's a bit of a problem is that it isn't the new cool thing. And so when you try to get developers in, they're like, oh, that's from 2012. What are you doing? And of course, that makes it a little harder to get help, from other developers. That's really the main thing. There are a couple of funky things with Knockout where you can get yourself into a memory leak situation, or if you have like a deeply nested tree, where observables can kind of be a little slow to fire because of the way it works. But for the most part, it hasn't been that bad. It's bad more from a personnel perspective as opposed to what you could actually do with it, which is an unfortunate thing in tech because this kind of happens all the time.
The thing is, it's not even that old. It's just older compared to frameworks like Angular and React. And it doesn't have all the things that these other frameworks
which
contain.
Is why I like it.
Yeah.
I don't have to go, okay, well, how does the Angular router work? I can just go, here's the page, here's the model, here's the stuff that's bound to it. Let me handle the calls back to the server. Like, I kind of prefer that, partially because our app, like I couldn't put Angular on there.
Yeah. Well, and when you were mentioning it, it was as in we are still using Knockout. We haven't gotten to the newer stuff.
Yeah. And I don't know if we'll transition off of it or not.
Yeah. The thing here, Joe, and we really do thank you for the comment. That's great. And it's started a little bit of a discussion too, with us. Just because it's older doesn't mean that it's not the right fit for your business needs. You use what works best for you.
Yeah. And I say this, and I agree with that. And bear in mind, I write Delphi code sometimes.
Yeah. Also understand that Will complains about everything. He could win $1 million and would complain about the taxes he had to pay on it.
Darn right. It's theft. That's what it is.
Yeah, see what I mean?
And if somebody's head just exploded in a car going down the interstate on the way to work.
I put that line in there because I was like, all right, pause, wait for Will to complain.
No, I mean, it's not so much that Knockout is bad. It's just there are going to be issues with getting people, but we're going to have issues with, hey, we're using old web forms too.
Yeah. So, Joe, send us another message with your contact information because we've got a Complete Developer water bottle just for you. And guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all our episodes to Twitter, LinkedIn, Facebook, and Google+. We're also on Instagram, Path, and Tumblr. You can check us out every week on Facebook Live and Twitter Live, where we discuss what's going on in the tech world and answer some listener questions. Or join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
Big thank you to our sponsor, Datadog, a cloud monitoring platform bringing full visibility to dynamic infrastructure and applications. Create beautiful dashboards, set powerful machine learning-based alerts, and collaborate with your team to resolve performance issues.
Datadog integrates seamlessly with more than 200 technologies, including Google Cloud Platform, AWS Docker, PagerDuty, and Slack, with fast installation and setup, plus APIs and open source libraries from custom instrumentation. Datadog makes it easy for teams to monitor every layer of their stack in one place. But don't take our word for it. Start a free trial today, and Datadog will send you a free t-shirt. Visit datadog.com/complete-developer to get started. Database normalization is the process of organizing data in a relational database. It was first proposed by Edgar F. in his 1970 paper, A Relational Model of Data for Large Shared Databanks. He was the first to propose the notion of a relational database. Normalization reduces the amount of space a database consumes. It also ensures that data is logically stored. It does so by eliminating redundant data and ensuring data dependencies make sense.
Yeah, and if you want to kind of get a basis for where this came from, look at what kind of storage was available in 1970 and what price it was, and that will kind of clue you in on why it's like this. Now, the normal forms are a series of guidelines to help communicate the level of normalization a database is in. There are 6, along with a few special named forms. They're listed in order 1st through 6th. In practice, you will likely not see anything beyond 3rd normal form, maybe 4th. I don't know that I've seen 4th. Each one adds on to the previous, so as to be in a higher normal form, a table must meet the criteria of all the previous normal forms.
We'll start by quickly reviewing the objectives of normalization as described by COD. Then we'll discuss some of the reasons why you want to normalize your database. And finally, we'll focus on the first 3 normal forms along with the Boyce COD normal form, then sort of briefly touch on forms beyond that. So starting off, objectives of normalization. The reason for first order normalization, and we'll get into what that is in a little bit, is to allow data to be queried and manipulated via a universal data sublanguage, such as SQL. Though COD specifically complained a lot about SQL.
It's got its issues. And my personal non-favorite thing about it is that it doesn't, the way that the language works means that you cannot ever have IntelliSense because it doesn't know what you're selecting from.
Well, it stands for structured querying language. And
yeah.
From what I understand, it's not very structured. It's for more than querying. And the language is, well...
Yeah. So it's like Ajax, really. Asynchronous JavaScript and XML that's not necessarily async, not necessarily JavaScript, and definitely not necessarily XML, but the word and is total truth.
Oh, yeah. So Codd listed 4 objectives for normalization beyond the first order. These were listed in his book, Further Normalization of the Database Relational Model. The first one is to free the collection of relations from undesirable insertion, update, and deletion dependencies.
And the second is to reduce the need for restructuring the collection of relations as new types of data are introduced and thus increase the lifespan of application programs.
The third is to make the relational model more informative to users.
And the fourth is to make the collection of relations neutral to the query statistics where these statistics are liable to change as time goes by.
Right. And by making this more informative and understandable for people, they don't mean the normalization.
Right.
Because let me just say, it is way overly worded and complicated for what it actually is.
Yeah.
And we'll get into that. These will make a lot more sense by the end of the episode once we've talked about what these normalizations are. But it's a good idea to have these objectives in mind when you are hearing about or reading about what the normalizations are. Why would you want to normalize your database?
Well, the big thing is, or at least the first major point is, you don't want to have to redesign your entire data storage every time you add something new that you want to store.
Mm-hmm.
It's more a matter of, it's kind of like object-oriented design. You only want to touch the part that you actually have to touch.
Yeah, normalized schemas allow you to add new data types a lot easier, and existing tables and structures don't need to be changed. Also, update errors or anomalies can occur when you have the same information in multiple rows.
Yeah, and this is especially painful when you don't have good transactions, which, I mean, early on, that was kind of dicey, the way that worked. Updates to one relational area require changes in multiple rows. For example, if you have an order form with customer information, like name, address, company, etc., on each order form from that customer, if they change address, you have to change it in all the rows. So if they move, you've got to do that. And that's kind of the idea here is to make that where, hey, this only happens in one place versus it having to happen in 5, and maybe it only happens in 4 because something goes wrong.
A lot of us tend to think in terms of these normalized tables when we're thinking of how to design things, because that's what we're accustomed to. That's what, the way object-oriented works. But back in the day, when this was first coming out, everything was procedural.
Right.
And you didn't have those discrete units.
Yeah, this is a thing from another time that, is kind of permanent.
Well, this was the solution to a problem from another time that we no longer have.
Yeah. Your average thumb drive that you pick up at Walmart, if you looked at what that storage is worth, in $1970, you couldn't afford it. Unless Bill Gates is listening to this podcast, you didn't have the money.
And if Bill Gates is listening to this podcast, what's up, Gatesy? We want you on the show.
Yeah, totally.
I totally called Bill Gates Gatesy.
Might as well.
So next, flattened tables may not allow for partial information to be inserted. This can result in being unable to store some information. An example that we're going to use sort of throughout the episode is one that I found on Wikipedia, and I really liked it, and it doesn't always fit, but it's a good sort of way of talking about things. And this is a faculty and course. Right. So you have faculty members recorded based on the courses they are teaching. So you'll have like faculty ID, name, hire date, department, course code, course name, description, etc., all on one.
And so, of course, the biggest thing that burns you there is if you get, let's say a new adjunct professor, right? So shiny adjunct professor walks in and we need to set them up. We don't quite have a course load for them. Guess what? If the table's not normalized and those fields are required, you can't put them in that table.
Right.
Which means that anything it's pulling from that table to have a list of faculty members for, say course assignment, they aren't in there.
Exactly. And on the other side of that, when deleting data, you may have to remove more than what's intended. So removing some information requires removing unrelated information. Back to this example, if, say, a faculty member takes a sabbatical, they're no longer teaching any courses.
They're gone.
Once you delete that last record of a course with them, they're out of the database.
Yeah.
Or you have to have a faculty member with null courses.
Yeah. Or you have to sit there and go, okay, well, I'm not going to delete that last record. I'm just going to keep it in mind that this person isn't really teaching that course, because that's what will end up happening, right? The office staff will try to hack around this.
Yeah. Oh, yeah. I've seen
some things.
I've seen some things.
Yeah, you work at the state. You've seen all kinds of things. I've seen how real estate data from the state looks.
Not even in state stuff. I've seen things at hospitals I've worked at other places where it was just, all right, there was a written out list of things. So yeah, it's interesting. So now we're going to get into these normal forms, and we're going to start with the first normal form. And these are their descriptions of different levels of normalization. We're going to go into kind of some detail on the first one, because that talks about like the basics of normalization, but then the ones subsequent are just adding on and building onto that. So the second form builds on the first, the third builds on the second, and so forth.
You almost end up kind of going through these as you're designing something. Like if you just have a wad of data, you sort of go, okay, I'm going to do first normal form on this, and then you do second. That seems to be the progression. It's not really, I don't think, intended to be that way, but it kind of fits the way you would break these problems down.
Well, these are, honestly, I think this is somewhat like, for us nowadays, design patterns. Yeah. Where this is what's observed.
Yeah.
Less than when they first came out, these were radical concepts. And I know some people who, especially our younger listeners, are going to be like, what? I mean, even for us, when we got into it, this was pretty much the way things were.
Yeah.
And when I say us got into it, I'm talking about back in the 90s when I was playing around with stuff in high school.
Yeah.
So, these have been around for a while. The first normal form starts the normalization of data by requiring that you have no repeating elements or groups of elements. You want to remove duplicate columns from the same table.
Yeah, and a lot of people are probably going, well, I don't think I've ever seen that. If you hang around long enough, you will.
If you've ever seen an Excel spreadsheet, think of that when you think of a denormalized.
Right.
Because you'll have, say, for example, your faculty denormalized Excel spreadsheet, you'd have faculty ID, name, like the faculty information.
Yeah, and then the course information.
And then the course is just like row underneath that. And then the next, and then row underneath that. And
yeah, one way to look at that is almost like first normal form might be the kind of way you would project the data out of the other normal forms. And, and just raw data would be that. So if you're almost undoing a set of projections, I guess is a way to think about it.
You want to create separate tables for each group of related data and identify each set of related data with a primary key. So going back to our faculty and courses example, which we'll be talking about throughout the episode, you would say take the faculty details and pull that into another table and keep that faculty ID on the course information to associate the course to that faculty member. Right. This would be the first normal form.
Yeah, so it's almost like you take the faculty information. If you were doing this in a filing system, you take the filing information for a faculty member, put it in its own folder. You take the filing information for a course and put it in its own folder. But think about the folders as not having text, but just having numbers. And you say, okay, this one comes from over here. Yeah. And that's how you would reference it. It's kind of how foreign key works.
Or you would have your faculty ID listed on there. Because I remember back before electronic charting in the hospitals, you'd have your faculty ID on there, and then you would just put that, because you had to keep behavioral charts separate from medical charts.
Right.
So the way we would identify them was just be the ID. So you'd go over here, you'd get your patient, you'd look up your patient information, you'd find their name, you'd get their patient ID, and then you'd go over to the behavioral charts and pull out their behavioral file. The values in each field of the database are supposed to be atomic, meaning they cannot be broken down into individual parts. And yes, you're looking at me, we've broken the atom, get over it.
Yeah. Yeah. And look what happens.
Right. This can be complicated because atomicity of a value may be business dependent. For example, you could have a name that contains first, middle, and last, but you don't need to break it down. You just need to know their full name.
Right. Because you never sort by last name.
Right. Or a string can have substrings.
Yeah. I mean, and I'll give you another example. At work, we actually have big wads of JSON data in some of the fields because it's like, hey, this is how this thing needs to, keep a certain piece of data for some control.
Mm-hmm.
And, we're not touching that as a business rule, but, it's there. And there's a huge graph of crap in there, but we don't ever index it. We don't need it.
Yeah.
At least, in that form.
Chris Date updated Edgar Codd's definition of first normal form to say that a table is in first normal if it is isomorphic to another relationship. So in that, there's no top to bottom ordering to the rows.
Right.
So you have a unique primary key per row. And it's not like the spreadsheet I was talking about before where you have the faculty information at the top, and then each row underneath of it has out to the side the course information for that faculty.
Right. And adjacent rows are not related to each other.
Right.
Is the other thing. So like in a faculty table, that may mean that the science department and the math department, their rows are interleaved based on when people started there, not based on what department they're in.
Yeah. There's also no left to right ordering to the columns. So basically the same thing, but on the column level. No duplicate rows. And every row and column intersection contains exactly one value from the applicable domain. So if you go back to our episode on domain-driven design, this is about what the business needs. And finally, all the columns are regular, meaning that the rows have no hidden components, such as the row ID or object ID or hidden timestamps, and breaking it down to functional units of information.
What do they mean by hidden timestamps?
Within the data, it's not...
just like loose in the... Okay, yeah. Or ID. I got you. So it's like, in other words, all the columns are out.
Yes.
They're not part of another column.
Yes, exactly. So your JSON object would not fit this definition.
Well, I guess it depends because we're not querying it, right? It's like if you had a dump of binary data, it's like it's not... used by the database. Like we're not trying to parse it out to do anything inside the database. It's just like put this here.
It's almost like you've got
it's a document database.
Yeah,
almost.
It's almost like you've got a document store in a relational database.
Right.
Makes sense. So next is the second normal form. And this continues to remove duplicate information by adding to the first and not allowing partial dependencies. You want to separate data that applies to multiple rows into different tables.
Right. So, we broke up the faculty, but let's say that the departments, instead of having that department information in every row, yank that out, put it in its own table, and reference it by ID.
Using foreign keys to create relationships between the tables. You may have a course, especially at the entry level, with multiple iterations within a semester. So Psych 101,
right?
You may have 5 different Psych 101 courses taught by 3 different professors.
Right.
And so you would want to pull out that course detail information and put that into another table so you're not repeating that for each one of those 5.
Yeah, and so that if you have to update it, you only do it in the one place.
Exactly. So like all the columns that are not the primary key are dependent on that primary key. Let's say with your courses, your course code is your primary key because that's your unique identifier for that instance of that course. So all of them connect back to that primary key.
Right.
And that instance of it. So if it was, say you've got like 5 different Psych 101s, well, the description is going to be the same across those 5. So that's going to apply to 5 different course codes. So you want to pull that out.
So I will say that probably some people are listening and going, okay, but I wouldn't use the course number as a primary key because it's mutable. And that's correct. We're doing this as an example just to explain kind of what's going on, because the way a human would look this up would be the course number. You make a primary key for the computer, guess what?
No. And if you're not a DBA or even an API developer, you're probably not thinking in terms of, all right, I'm going to use the row ID for that to look it up or whatever primary key you're using.
Yeah, you're still going to look it up by some sort of natural key.
Yeah.
Even if you go, okay, I don't know what the primary key is. Well, I know the course number. Well, I'm going to have an index column for that, and I'm going to look it up.
Mm-hmm.
So each column should describe what the primary key identifies. And this groups data into logical dependencies or tables with associated information.
Yeah. You have, for example, customer information separate from product information, and you join them based on their primary keys.
Yeah.
The next is the third normal form. And if you can't tell, each one of these just adds a little bit more constraint onto what you can do within your database. So the third normal form adds to the second by not allowing non-transitive dependencies on anything but the primary key. So if it can exist without the primary key, then it doesn't belong in that table.
Right. And so this is sort of like what we were talking about with the domain-driven design. If there is an entity that can exist under an aggregate root, but it can exist without that aggregate root, it's an aggregate root.
And you want to remove these. Yeah, you want to remove these dependencies between the columns. Going back to our faculty and course example, your faculty information can live independent of your course code if you're using the course code as a primary key, so it doesn't need to be in the same table. Or another one would be another transitive dependency would be if you had faculty email and department. Those are transitively dependent. A faculty member would have one email address and only be associated with one department. And you can obtain the department information from the faculty member's email and vice versa. So the dictionary definition for transitive is if it applies between successive members of a sequence, it must also apply between any two members taken in order. Basically, the relationship between elements has to be the same across the table and to the primary key. So transitive would be A is greater than B and B is greater than C. Therefore, by transitive properties, A is greater than C.
Right. And
or to put that into numeric values, 10 is greater than 5. 5 is greater than 3. Therefore, 10 is greater than 3.
Right. Yeah, the big deal here is that the columns should be dependent on the primary key and not other columns in the table, because otherwise you don't really have a primary key.
Mm-hmm.
Like if you're having to look it up by the primary key and something else, the variance in that thing makes a difference, then that's probably not correct. And it isn't correct for third normal form. So the next one is Boyce-Codd normal form, and that's abbreviated as BCNF. The others were, 1NF, 2NF, 3NF.
This is also known as third and a half or 3.5 normal form.
Yeah, which, I guess somebody thought by this point they needed to be cute.
Well, it kind of comes down to the way this came about, and it was created after the normal forms. Raymond Boyce and Edgar Codd in 1974 came up with it specifically to address some abnormalities that were not covered by third normal. So Boyce-Codd normal form adds to the third normal form by requiring that all determinants are candidate keys. So every dependency must either be trivial or contain a super key. Now, a trivial functional dependency would mean one that is a subset of another, and a super key is a unique identifier or set of identifiers that's unique to the entire schema. So a candidate key then is the minimal information that you need to create a super key. So going back to our faculty course example, a candidate key would be the faculty ID and course code.
Right.
With that information, you could get everything you needed out of that schema. When you do this, all the redundancy based on functional dependency has been removed.
The way to say this informally is that each attribute must represent a fact about the key, the whole key, and nothing but the key. So in other words, if you've got columns in the table that are, the table's primary key is the faculty ID, but you've got columns in there that really aren't based around that. That's like their, the size of their chair or something, like that's not really related to the ID of the faculty member, and it's not determinable just straight up from that. So that's kind of what they're trying to say here. It's, again, I went through a database course. I went through a very good one at Lipscomb. I think probably the same teacher still teaches it. And it was still very challenging to get to where you could actually describe all this stuff versus just being able to use it.
Now, the interesting thing here is that most of your third normal form tables are going to meet criteria for Boyce Codd.
Yeah.
A third normal form with no overlapping candidate keys. So if the simplest amount of information you need to have a super key and be able to get anything in that schema, if that doesn't overlap with any of the other ones, then it meets this. Multiple overlapping candidate keys may cause it to not meet Boyce Codd criteria, being not dependent on the functional dependencies.
Now, beyond Boyce Codd, you go down the rabbit hole. And I remember doing this in class and just thinking, man, when am I ever going to use this? And it turns out never thus far. It's nice to think about it, right? But the previous normal forms have been concerned with functional dependencies. Fourth normal form focuses on multi-value dependency. So that would be a dependency is, let's talk about what a dependency is. A dependency is when information in a table determines other information in the table. A multi-value dependency occurs when one or more rows in the table imply the presence of more rows in the same table. So, like, for instance, I think this would be a thing, like if you have an order detail line that says, hey, how many order details are in here? And you've just got 2, but both of the records say that there's 4. Like that kind of stuff, you would obviously want to fix that. For any non-trivial multi-value dependency, there must be a super key involved. And I'm trying to think of a good way to explain this one.
They use all these huge words to describe these things.
And it basically all comes down to the dry principle.
Yeah.
Don't repeat yourself. So fifth normal form isolates semantically related relationships. Anytime you see the phrase, by the way, related relationships, where you start seeing like, it's like, this isn't you seeing double. This is the person that wrote it seeing double. And that ought to tell you something. A table's in fifth normal form if and only if all non-trivial join dependencies are implied by the candidate keys.
So let's break that down.
Yeah. Why don't you do that? Because these are hard.
I know. So what does non-trivial mean?
It depends on who's saying it.
In database terms. When Edgar Codd says it, what does non-trivial mean?
Yeah, see, I don't know how you would say that. I guess that would be the case if each join dependency is a super key.
Mm-hmm. Yeah. So it's really rare for a fourth normal form to not meet the criteria of fifth normal, and you're starting to get really pedantic at this point.
Yeah.
I mean, it's already very pedantic where it's just one little change between each one, and that's why most databases are around third normal.
Right, because it's a compromise.
Yeah.
And that's OLTP databases, by the way. When you get into OLAP, that's a whole nother can of worms.
Well, yeah.
Because, anybody that can purchase a, data warehouse software and have the servers to put it on, like hard drive space, not their concern. Not like that.
Yeah, that's very true. No, but with this, with fifth normal, your join dependencies, basically it's saying that every join table is only candidate keys. So every join table you have in a schema
is only 2 keys, basically.
No,
or
is
the keys from the 2 sides?
No, it's basically saying the information in that join table is a candidate key
for the table itself.
Yeah, it's for the schema.
Right.
So
it's a join between. Yeah, I got you, because that's going to be unique.
Yeah,
from
so
those two.
For our faculty example, we've only got the 2 tables. We've got faculty and courses. So the one join between them, like it would actually meet fifth normal, because the one join between them would be faculty ID and course code.
Right.
And so that would be
and those would be the only
key.
2 in the table. Whereas probably what a sane person is going to do, and this is why we do third normal form, probably no further, is they're going to say, okay, well, I've got a faculty ID and I got a course ID, but hey, I also need to know when this course is being taught. And there's other stuff, like that thing is an entity by itself to some degree, not an entity in a DDD sense, but like it's got other stuff with it for that record.
Right.
Whereas this is more like, hey, let's break this down and just say, oh yeah, they're teaching this.
Mm-hmm.
And that's all there
Unless
is,
there's a lot of information in there and then it's broken into a third. And so you could have a join with the 3 columns, which would be the course
like for
information.
instance, the classroom schedule record.
Yeah.
There might be another record off to the side that's like, hey, here's these 2 and here's where that happens.
So everything in those join tables would be super keys. So where you could get all the information you needed out of the database with just those 2 levels of information.
And you will occasionally run into stuff that's built out like this.
Yeah.
And most of the time the people that do that, like if you said, oh, you're using fifth normal form, they're just going to look at you. And like this isn't somewhere you get because you wanted to get there. You got there because you had to get there based on what you needed to store.
Finally, a table is in 6th normal form if and only if all of its joined dependencies are trivial. So the idea here is to break the data down into irreducible components. Tons and tons of small little tables.
Right.
And tons of joins.
And this kind of stuff, when you see sample databases that are using this, like I don't know that I've really seen a whole lot of production databases where this is like true across the database. You'll see it in spots. It's kind of like the pattern soup that you see in like enterprise Java apps sometimes, like the factory, abstract factory type stuff where it's like, oh, this thing has one function and only one function, and here it is. And if you want to do some other function, it's over here, and then we got to have a thing to bind those two. So
when I first started reading into this, the first stuff I found had 6th normal as only theoretical.
Yeah.
However, I did find some actual use cases for it. This can become important when you're adding in historical data that has changes over time.
Right.
It's also used in some data warehouses where the benefits of using less storage space outweigh the cost to retrieval by having so many tables.
Right. And there's use cases for this, right? Like if you're pulling in a lot of sensor data and stuff like that, like you've got, 50,000 devices sitting out there and they're sending telemetry and you've got to write that in. You want to write as little as possible and not duplicate if you're storing like 10 years worth of data. I mean, there is a use case for this. It's just not anywhere I go.
Database normalization can help you better organize your database. Even if you aren't a DBA or a backend developer, understanding the basics of how the relational databases are organized can provide insights into working with other developers or with their existing code.
Yeah, I think the big deal here is that it's not so much that you need to be able to go, okay, this is third normal form. It's you need to understand kind of the progression and how you would structure a database and how that structure gets broken apart to reduce dependencies, to make it so you're not writing data to a bunch of different places, that kind of stuff. Like understand this, but don't necessarily go, oh, this is 3.5 normal form. Like that's not a...
Well, what's funny is our senior front-end developer, he has a degree in computer science. And our boss was talking about how she wants the databases built. And this was when the API developers were trying to get rights to build tables in dev, just so we could test and try things out before we got the DBAs involved. And so she was talking about that. And he said, I think all of our schemas should be third normal. And that's actually what led me to create this, because I'm like, I've heard those terms before. It was a long, long time ago, because even you and I didn't get into this, because this was just really heady computer science stuff.
Well, because the thing I taught you was like, don't repeat yourself in the database.
Yeah.
Like that was kind of the extent of it. It's like, I'm going to teach you how to do joins and make sure you can retrieve data and you can put data in, you can write a stored proc.
Even going through the SQL courses I did, they didn't talk about this kind of stuff. This is very computer sciencey, heady kind of stuff. And when he mentioned that, I was like, I remember that vaguely from high school programming classes. I ought to look into it. And that's what led to this episode.
Yeah, I think it's a lot, it's like you said earlier, it's a lot like design patterns. Like, a design pattern is like a door. Okay. Some dude lived in a mud hut and decided, hey, I don't want to climb out through the roof. So they made a door. 5,000 years later, We all have doors.
And we don't think about what happened.
Yeah, it's like, I need to get in the room. I make a door. It's not is it, like other than a carpenter who's just really, really into construction, you don't think about the front door of your house very often. Unless your door's like mine and it's got a giant crack in it that's letting cold air in.
Oh, I was actually going to say, unless you play Sims, and then doors are important.
Yeah. But I mean, it's a very context bound kind of thing. It's not, it's nice to know these terms and to be able to go, okay, yeah, here's what this is. But I've never had somebody go, can you explain the difference between second normal form and third normal form? Even though we use both in development, right? Like we move through that. That's not a thing. Unless you're getting interview questions from somebody who probably shouldn't be giving you the interview.
Well, it sort of depends. If you're interviewing for a SQL developer or a data DBA position and you're straight out of school, so they can't really ask you a lot of experience stuff.
Yeah, then they might hit you with that.
Yeah, I would.
Yeah. Well, because you don't know what to ask them.
Yeah.
I mean, at that point. But for the real world, you're not going to have to know the difference between these, but understand the progression. Mm-hmm. And then you're good.
Yeah, and the differences are so minute and get to the point of being pedantic.
Yeah.
That it's sometimes it's a difference of how you describe it.
Yeah. And sometimes it's really nice just to throw these out just to, see the DBA just turn and look at you and give you a dirty look. That's
fun.
Yeah. Honestly, that's probably what I've used it for more than anything else.
Mm-hmm. So normalization may not always be the best idea, depending on what your business needs are and how far you go down this rabbit hole of normalization. Also, it is possible to hurt performance by over-optimizing one aspect of the data retrieval and manipulation.
Yeah.
This has been sort of a brief overview of how a relational database is organized. If you're interested in more, follow the links in the show notes for an even more in-depth approach about the topics that we covered and more than we could get into in a single episode. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I just want to throw out the idea that you should be aware of trade-offs. We talked about the different normal forms of a database. And if you get somebody that's really, really into this, because I've run into a few of them, right? They want to over-normalize a database, and you don't want this happening in your production OLTP database. And the reason is it's kind of painful. Sometimes you do want to denormalize and flatten data out because you need to retrieve it quickly.
That's usually why you use a view.
Yeah, there's that. But the thing is joins have a cost.
There's that, yeah.
Yeah. I mean, there's a lookup. There's lookup costs and all that kind of stuff that go on. There's also things with locking behavior. So like as you're writing to a table, you don't want to have dirty reads. So what you do is you say, hey, this part of the table, don't accept any reads from it. In other words, wait and let me finish writing, and then you can read. And so what ends up happening if you're not careful is, let's say you make it too complex. Okay, your writes are now really easy because they're theoretically, little thin parts of the database, right? It's just little bits and pieces in a bunch of different places. But your reads, when you need to get all that data back and pitch it back over the wire in a web request, those get huge because you're joining 15, 20 tables. So you don't want that. On the other hand, you don't want your read performance to be like super optimized either, where you've got so many indexes that when you write, it takes forever. So always understand the trade-offs. There's trade-offs between read speed and write speed in a database. There's trade-offs between disk I/O and memory, just on a desktop computer. There's similar ones between network costs and compression costs. Like if you're overly compressing data versus and you're doing it over a high-speed network, you may want to not compress it as much because of the CPU cost when you can just get it over the network. That doesn't happen often nowadays, but there was a time when that was a concern in either direction. So just always be aware that when you start going, okay, I really want to be pedantic and I really want to push on this one thing, know what the trade-offs are, because you can really get yourself into trouble and you look like a jerk after everything's blown up. That's all I got. If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Look for us each week on Facebook Live before we record each episode. Thanks for listening. See you next time.